Hey, we've got another power supply on the bench. This is another E3611A. I've done an earlier video on another one of these. I've got myself a second one for a good price. This one I'm making a video on because it actually has a problem to fix. The other one was just a bit of a teardown and it turned out that it was working fine. This one actually does have a problem. If I turn on this display, it's kind of a bit weird, not displaying stuff. Sometimes the current comes up at like a couple of amps. There we go, in that range. All sorts of weird stuff going on. So it does output a voltage, but it seems a bit funny. Also, I've noticed that this pot isn't a 10-turn pot, which the voltage one here is, and on my other power supply, they're both 10-turn pots. So it seems like someone may have been inside this one, which means we're going to have a bit of an adventure to undo what has been done and fix the previous fixes. So I'll unplug that to make sure that we don't get ourselves zapped, and from memory the front and back just come off just like this with the screwdriver. I'll do both ends at once. And then the underside. Alright, so that piece just comes off, and the front we can kind of carefully take it away a little bit and see what we find inside. Now there's nothing immediately... Oh yes there is. Oh boy. I was going to say there's nothing immediately obvious, but we've got a capacitor that has just blown its guts out its backside. Oh boy. Gonna have a bit of a clean up there. So that's a United Chemicon too. No, that's a Nichicon. Nichicon cap that's literally blasted itself out. That's like one of the worst I've seen. Usually it's just a little bit or it's dried up. That's fresh. And yep, the pot up here is different on the left. You can see the blue pot. So that will be replaced with a nice 10-turn Bournes. And the Bournes 10-turns are a little bit expensive, so whoever's gone to replace that has gone a bit cheap. Unless that's just how it is. But hang on, let me just check my other power supply up here. Yeah, the one I've got up here is like 10-turn. This one is not. I wonder if maybe it has been replaced. It's got a moulding that kind of holds the pot there, so I can't put the same round one in. I might have to take the other part apart, the other power supply apart, and just double check what part is in there. But yep, this one is definitely candidate for capacitor replacement. No, the other one down here, that's kind of blown out a bit too. So I'm going to replace all the capacitors. All the caps have actually busted, it seems. Geez, 1, 2 and 3. Alright, well that's the first port of call. We're going to take all this apart, get this PCB out, neutralise all that stuff, pull those capacitors out, clean it all, neutralise it, see what damage has been done to the actual circuit traces. Looks like we've got a bad diode. Oh no, it's had diode here has gone a bit funny. I think that's a little diode, CR8 it's called. Might have to have a look at that one as well. And hopefully we can get this thing working. It does operate after a fashion, so it's not completely dead, which is a good thing. So I'll make a list, and let's see what parts we can get, and see what we can do about fixing this thing up. Here's the other side of the board. I'll zoom in. You can see all the goop there. That going to focus. I'll zoom out a bit. There we go. Oh, here. It's come through this hole. That lined up with this peg here on the case. See all the goop there. So that's so that's going to have to be cleaned off, and the trace has gone a bit oxidized there, so I'll have to scrape that back, scrape the solder mask back, clean it, make sure that there's no problems, maybe even tin it, and then I'll go over with some clear nail polish or something, just a clear lacquer, just to seal it back up again so it doesn't continue corroding. maybe I'll seal it up. Actually, sometimes I don't seal them up because if you don't clean it perfectly and you seal it in, it's going to corrode. So if I tin it, it might be good enough just doing that, just with a soldering iron. So let's just have one last look before I go and clean this all up. You can see there the goop is just terrible. It's still wet as well. So hopefully that will come off relatively easy, seeing as it's still wet. It shouldn't be all like hardened on there. But it's gone all over the board, all the way down here, all the way up here, up to underneath these the pass transistors. On the heat sink, you can see here where it touches the board on both sides. It's just gone everywhere. I think this one is a main culprit. Just bleh. Stinks too. And these two smaller ones seem to have died as well. Died to death. These two here, this slightly larger one, is what, 220 microfarad 100 volt, and the 4700 microfarad at 100 volts. They seem pretty good, but I'm going to replace them anyway. The goop that's on there is from the other capacitors, but I'm going to replace a whole lot anyway, just because I'm not going to take any chances. So yeah, time to start scrubbing, see how good this board comes up. So I went down to Akihabara today and got a new pot, 10K Bournes 3590 S series, the same series that's sitting there. But that's going to go in place of that single turn current dial, because this is a 10 turn pot. But I found out there's one little problem that's a little bit of a hiccup, is that this is a round shaft. And see that there, if that's, hopefully that's focused. This one is not. This is a flatted shaft, or a flat side shaft, and that's because in the hole there, it's got a, just about there, you can see it's got a flat section. So that slides on and then gives it grip, you know, so it'll turn the pot when you turn the dial. This doesn't have that, because this is designed to have like a either a clamp style knob or one with a grub screw on the side. So I might, that shaft is stainless steel, so it's going to be a bit of a pain to file it down. I might see what they're worth on like DigiKey or Mouser and maybe grab one if they're not too expensive. But I can only get the round shaft in Akihabara, so I might take to that with a file if the Mouser / DigiKey ones are expensive. If not, I'll just buy one and this can go in the junk bin and I can use that for something else. 10K pot, pretty handy value to have. So that is going to go in there, but you can see I'm going to have to do something about this. That little ridge there, that little piece, that's going to be in the way. Now the weird thing is that there is no mention of that in the service manual. The service manual says that this pot is a 10 turn 10K pot. This one isn't, and it looks factory fitted. So I'm not sure what's going on there. My other one that I've got, which is the same part number, E3611A, I've got another one just sitting up there. It's got 10 turn pot in both positions. I checked it. I got the part number so I could match it up with this. And well, except for the fact that it's got a round shaft. But yeah, so I don't know why this has been fitted with a 1 turn pot. It's not a modification as such, because it's got that little side piece there to stop the pot from rotating if you turn it too hard at its end stop. So it's designed in from factory. I don't get it. So I'm going to probably just snap that off when I put the new pot in, the full size one, the 10 turn pot, and yeah, just make it work. Here we are with a board basically repaired. Took quite a bit of work on this. You can see there's some nice shiny bits, nice silver bits there. Basically what I had to do was remove the solder mask from the damaged traces and then repair them. They weren't so corroded that the traces were missing. Sometimes if you have an older unit that's been corroding for a long time, the traces will be actually like corroded away to nothing, and you have to put jumper wires in and stuff. You can just use a bit of bare copper, the tin copper wire, and remake the shape of the trace and solder it down and glue it down and whatever. But that wasn't the case here. I caught it relatively early. But I basically had to peel back all of the solder mask on the affected traces. So I used a little flathead screwdriver, like that one. And also sometimes I used a scalpel with a flat chisel tip. And just carefully scrape it away. so I exposed all the copper. The copper is slightly raised up from the substrate, so you can carefully kind of like scrape along, and if you're careful, you don't scratch up the fiberglass too much. But once you've done that, I use one of these things. Little handy device. It's a you turn the end and it comes out at the other end there. Fiberglass little brush. You get these on eBay. They're not too expensive and they're really fantastic for polishing up the copper traces. You know, scratching away all the oxidation and the contamination without actually damaging the copper itself too much. So once I'd scraped off all the solder mask, given a wipe with isopropyl alcohol, I went around and polished it with this thing. Another wipe with isopropyl alcohol. Then I doused it in flux. The old Hacko 001. I've got 2 bottles of this. 001-01, 001-02. The -01-02 is just a package size, but this is Hacko 001 flux, just standard rosin flux, nothing special. Bigger the glob, better the job, so I just put on enough to make a even Lewis Rosman blush, and soldered over the top of it. Once after it was all clean, of course, soldered it down all over the traces. A lot of solder. Then I was using the solder sucker here because it's a much higher wattage than the actual soldering iron that I've got for the larger traces. And then a bit more flux and sucked it all off again. You don't have to suck it off, but it was mounting up pretty high and I didn't want to cause problems under the components and stuff. And that basically I tinned the copper to protect it. Once I'd cleaned all the oxidation off, I can't leave it bare. I was going to oxidize in the oxygen of the air again. So the tinning protects it, and that's what you got. Nice silver traces. Almost looks like a professional job. Worked out quite well. A few on the back there where the fluxes come through the vias. Didn't actually eat the vias out. Occasionally you get that problem where the flux will sit in the via and just sit there eating it away. An earlier video of mine, you'll see I've got a Onkyo which I repaired, which had that problem. A supercapacitor actually leaked and ate out all the vias in the board and was stopping the thing from booting, so managed to repair that using a similar process as this. But that is all the traces repaired. Quite a few of them in the middle there. All around in here and up to here. Also, I've replaced the heatsink there because the old one, where is it? Here it is. The little foot, or the little leg there, corroded away just enough that where they stamped through to crimp it, had corroded away and that leg fell off, so that was a little bit wobbly in the wind. So I got a new one. It's exactly the same. It looks exactly the same, except it doesn't have, the new one doesn't have this little boss in it, the screw boss. So I just used a M3 nut and screw, put it in there, and it's nice and solid again. Now, one thing to note with these heat sinks and bolting things to heat sinks: never solder, then bolt the device down. Always bolt it down, then solder. If you bolt first and then solder, you're not going to have any stress on the legs. But if you solder first, then you bolt it in place, when you bolt in, it's going to like pull into position and it's going to put stress on the legs. And you can crack the silicon die, or you can stress the circuit board or the solder joint, and you're going to generally have a bad time. So always bolt it in place, so that way you can seat into position, then solder it. That way you got no stress on anything in there and it's going to be fine. The other thing I did was I replaced the diode here because that was blown out, probably from all of the part of all the problems here. That is actually a what does it say here? A14B is what HP recommend. That's their specified part number. You can't get them. I can't find anywhere with them. I can barely find any information on that diode, but it does cross-reference to a 1N5059 is which I've put in there. They're pretty common, not too expensive from DigiKey and Mouser, so I put a new one in just there. It's just a protection diode. It seems to be for this transistor here and some other stuff. So yeah, I tested that transistor. It tests fine, so I just replaced the diode and left it at that. Apart from that, that's pretty much all I've had to do on this board. Everything else seems good. Oh, of course, I've replaced all the electrolytic capacitors with brand new Nippon Chemicon or United Chemicon, depending on what part of the world I bought it from. But yeah, it's all pretty good. It's got to give it a clean up, get rid of all the old flux, and that's basically ready to go back in. Now, I did find that the path transistors were busted. So the old ones were MJ3042s, these two here. But you can't get them anymore. They don't make them anymore. The TO3 packages are a little bit hard to get sometimes. But they do cross-reference. So HP recommend a 2N6055, which I've got here. In my other units I've got, they've actually got a 6056. The main difference between the two is that the 6056 costs substantially more, like $10 more per piece or something ridiculous. The other difference is that the 6056 is rated to 80 volts, where these are rated to 60. Now this is a 0 to 35 volt power supply, so the 60 volt part is fine, and it will save me about 20 bucks to use the cheaper part. So that's what I'm going to be using. So if I get the old eBay tester here, this one I've put in my own case, but it's a standard LCR-T4 or something. And let's have a look and see what this thing says. So this is a 3042. This is the busted one. If I hit the button, it's telling me it's a diode now. Well, hang on, let me just make sure I got these on. These are busted, but I didn't realize it was that busted. Let's try it again. Yep, there we go. Okay, so it was just a dodgy connection. So it's an NPN, which is correct. HFE of 1. That's not correct. That's basically no gain whatsoever. It's not going to be working very well at all. The other one reads the same, HFE of 1. So the new ones, let's hook that up. Make sure we've got a good connection there. And that one there. And what does that say? 37. HFE of 37. So these are perfect. These are fine. And these two read about the same as well. HFE value, the absolute value, isn't so critical. Like if it's going to be a large range, and it does change depending on the voltage and the current you're passing through the device. But if it's wildly different to what the datasheet says, or if it's outside of what the datasheet says, it's definitely bad. So yeah, the datasheet for these might say anywhere between 20 and 100 for the HFE, and if it's within that range, it's fine. Generally, don't need to match the transistors unless it's a critical application. Something like this doesn't really need to be matched. So these two are fine. I think one of them's 25, and the other one's like 37 or something. I can't remember exactly, but they're close enough. We got the little pots here to calibrate it back into spec. So that means we're on to the next step of putting this thing back together. I've got to put the transformer back in here. This transformer here, just it's a little bit heavy, which is still connected to the heatsink with the power connector. But yeah, the heatsink there goes on, then the TO3s go in, and we can basically, I think, turn it on and see what happens. Cross our fingers, close our eyes, switch the thing on and hope it doesn't go pop. Oh yeah, on the front, I'll talk about the front panel too now. So I am replacing the earth connection with a green connector because it was red, black, which I didn't like. It's red, black, so red and red for the output terminals and black for the earth. I don't know why they're different. I don't know what the go is there, but I prefer red, black and green for earth. Sorry, for positive, negative and earth. Red, black and green in sequence, because it means I've got that visual sort of like I can see. Yep, green is earth because I'm a bit dumb and I don't want to connect things backwards by mistake. So I've got a green one coming. You can get the green and you can get blue on eBay. The red and black you can't really get anymore. I don't know why. They don't seem to make the red and black colours anymore. They're an aftermarket one you can buy, and they do look like these HP Agilent sort of connectors, and they're a 95% match. They look pretty good. So I'll be putting one of those in there once it turns up. Also, I've replaced this pot. So I went down to Akihabara and got my pot. This is the old one, the single turn. Got a 10-turn Bourne's pot. And there's an interesting thing that I've got to figure out what I'm going to do with this, because it's a 3590S is the old part, and the new part is a 3590S. The one on the left, the original one, is an A17-503. That's A17 is like the series or the specifics of the design. And sorry, the 3590S is a series. A17 is the specifics of this design, and the 503 is a value. It's a 50K. This one on the right is a 3590S, same series. A26, something slightly different about it, and it's a 103, which means it's a 10K. All well and good, except it only came with a round shaft. The Bourne's pots these days, 3590S especially, only come with a round shaft. But these are a D shaft. Where's the knob? So this is a D shaft knob. So it won't go on, which is a pain. But turns out that the shaft is brass, as I was thinking it was going to be stainless steel before. But it is brass. So I filed it down, chucked in the vise, filed it down, and the knob doesn't fit. It's too loose. Because it's a metric shaft, and they're all metric shafts. The old ones are imperial shafts, so that's a 1/4 inch, 6.35 millimeter. This is a metric shaft, 6 millimeter, so I'm 0.35 millimeter too small. Pain in the bum. So I've got a few ideas. I'm still figuring out what I'm going to do, but I'll be back to you soon once I've figured out exactly how I'm going to make that knob stay there. Maybe some JB weld, maybe a brass shim. I'm not exactly sure yet. I have to figure out what's easiest for me at the time. But anyway, that doesn't stop us from turning the thing on and figuring out if it actually works. So I'll get this thing back together, be back to you soon, and we'll see if we get any sparks flying. Alright, moment of truth. Time to see if this thing works or if we're going to have a slightly longer video. I've got the multimeter here connected into the input, down here. Power's connected on this side, just here. And we're ready to turn it on and see what happens. Now the display, I can kind of lift it up so you'll be able to see it. I can't really turn it around to be level, but you'll be able to see the numbers anyway. So let's turn it on. And nothing. At least it's not flashing. Before it was flashing and doing all weird stuff. What about in the other range? Nothing still. Okay, so we're not getting any output. The current set... Let's have a look here. The current set seems to work. So I can set my current, but I can't actually get any voltage out. Let's turn that off and unplug it. So, next order of business will be, I guess, checking our semiconductors. They're the most likely things to be dying. 2 bridge rectifiers, I'm going to assume they're okay. I might give them a quick diode test. But yeah, I'll have a look at these semiconductors, because they're the most likely thing to die. Diodes and resistors generally go pop, or they burn, or they visibly discolor if they're putting too much power through them. But semiconductors are a lot more sensitive, so they're more likely to die than a resistor that looks okay. So I'll have a bit of a test, and I'll be back to you in a sec once I've got something figured out. Alright, I found the problem. It's a bit of a PEBCAC error. Problem exists between keyboard and chair, or in this case workbench and chair. I'm going to leave this in the video because it's embarrassing and it's funny. I'm probing things around. I've got the schematic here. Golden rule, thou shalt check voltages, right? That's the first thing you check. So I'm checking this. Yeah, I've got 4.9 volts where I should have 5 volts. That's perfect. 11.9 volts, negative 12, all that sort of stuff. All the voltages are good on the control side of the circuitry, but I'm not getting anything coming out of the main windings for the main output. That's this here. So I'm thinking, oh, this is bridge rectifier dead, because I'm checking here. I check the input to the bridge rectifier. Nothing there. Oh, is my transformer dead? Nah. This is what happens when you work at 2 in the morning. I forgot to solder the transformer leads in, so they're not making contact. Geez, I'm an idiot. So the control voltages, the little wires must be just touching on the pad, you know. But the ones for the main voltage, these big fat traces, they're a larger hole, so the wire mustn't be touching. It's just hovering in the middle. So I'm going to go ahead and solder those up, and hopefully it works. Idiot. All right, ladies and gentlemen, the transformer is now soldered in place, and we're ready to turn it on. Take 2. Fingers crossed, Freddy. Oh, we're getting voltage. It's a little bit out. I'm going to have to tweak the pots and calibrate this thing. Let's go up a bit. What do we got? 22.7-ish, 21. Yeah. Let's go up further. Yep, we're getting voltage out. Awesome. The other range there. Perfect. Look at that. It's working. It works when you solder it together properly. Awesome. Alright, let's get a load. I'm not going to actually do the calibration process on camera because it's a little bit tedious and a little bit drawn out. It's not that complicated. There's only 3 things to adjust, but I would sit here tweaking this and tweaking that. It's going to get boring. More boring than the video is already, so I'll leave that alone. But basically what we want to do is get a 0.1 ohm resistor, which I have got here. You need a 10 watt. This one is all ganged up, so we've got 20 watts worth here. I've got 10 1 ohm resistors. I've measured that with my 4-wire resistance function on the 34461A, the Keysight 6.5 digit multimeter, and this is at 0.1020 ohms at 25 degrees, so that's going to be fine. And we've got to hook it up so that we're putting all the power through that resistor, as you can see in the diagram here, straight across through 0.1 ohms, and we're measuring the voltage across that, and that will then give us our current if we do a bit of a basic division and multiplication and whatnot. So basically it says you turn it all the way up, both dials to full range, and then you want to get on this one 3611A, you want to get 0.158 volts on the meter, and then you adjust some stuff inside to get it all correct, and then you do the same with the low current range, and then you can do the voltage, the voltmeter. So I'm going to go ahead and do that, and then once it's done we'll get this thing back together, cleaned up, and give it one last test. So we're done, ready to go. As a quick overview of what we've done, replaced the electrolytic capacitors with new, cleaned off all the electrolyte off the board, scraped back the solder mask off the traces that were affected, and tinned those to make them nice and shiny again. We've replaced the 2 pass transistors at the back here with 2N6055s, added some heatsink compound, some thermal paste, because the amount that they used was actually a little bit embarrassing. It was barely a token amount. So I've added some Arctic Silver just because I had it there. There's no reason to use it, a bit overkill, but I had this stuff to hand, so that's what I used. You can use just a normal silicon paste, that is absolutely fine. Just use just enough to do the job. Don't want to use too much there, and you don't want too little, so just the right amount. Replace the heatsink here with a new one because the mount was corroded and it was flapping in the breeze. Replace the protection diode here, and replace the 1-turn pot on the current dial with a 10-turn. If we look at the front panel, we have got a green binding post for the earth, so we've got positive red, negative black, and green earth, as things should be. The current pot has the knob installed now, nice and firm. I ended up just globbing a bit of JB Weld inside the knob, put a bit of tape around to stop the drips, and stuck it on there and kind of centered it as best I could. It's got a little bit of run out, maybe 0.1 of a mil maybe, but that's fine. I'm not going to complain about that. It's working perfectly. Now, as for why this thing died, I've got a theory, one of 2 reasons. Either someone's pumped too much voltage in, because this thing can handle, it says on the front panel, 240 volt DC max to earth on the positive and negative, from the positive and negative to earth. So either someone's pumped too much in, or not to earth but across the positive and negative, like back EMF or something, or they've reverse biased it and pumped the voltage in backwards. That would have caused, I think, what happened here, because this diode is a protection diode. It's reverse biased, somewhat reverse biased across the output in a way. So if you put voltage in, that's going to start shunting that as a dead short, and if you exceed its wattage rating, it'll go pop. That will then remove that protection, allow you to boil the electrolyte in the capacitors. It's going to leak, and then also the pass transistor is going to get a hit, and that's what I think's happened. It's just a chain reaction, bang, 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 and the power supply stopped working because someone was a little bit silly with the inputs, or the outputs being used as inputs. So that is all good. It is reading spot on as well. So actually I'll leave that up like this, and I'll inset some pictures of the multimeter, and we'll turn this on and I'll show you that it is actually working. So that is now on, and if we go to, let's go full scale. This is in the low current mode. Let's go to the high current, the high current mode. Let's go to low current mode, 37.9, and the display, we have to let it settle for a little bit. Alright, 39.1, and we're reading 39.1, so that's fine. The current rating is also spot on. I've got to hook up a current shunt, and there's a little calculation you do, the voltage that you're reading across the shunt divided by the value of the shunt, and blah blah blah. But it is spot on. I've calibrated it using the pots and with my 4Y measured little current shunt there. That is 0.1020 ohms at 20 to 5 degrees. That's 20 watts. It's a bunch of resistors, so that's all good. So now all I have to do is put the case on and put it back on the bench, and it's ready to use. So 2 enthusiastic thumbs up. We're done. So I'll unplug that before I touch anything I shouldn't. And yeah, that's it. So if you enjoyed that, give it a good old thumbs up, and hit subscribe if you feel like it. We'll see you in the next one.